All right, this is Dr. B, and welcome back if you're a new viewer or if you're just watching us before. I'm streaming every Tuesday, Thursday, and Sunday night at 8:30 p.m. Eastern Standard Time. So that's right now, wherever you're at. So I'm just outside Washington, D.C. Tonight, we're going to look at moles to grams. And the big deal here is what happens is when we get to moles to grams, sometimes students don't quite get the concept, and then everything snowballs because so many things in chemistry are tied back to this moles to grams conversion. But it's really pretty straightforward. So by the end of this evening, you're going to be really good at converting from moles to grams, grams to moles, canceling out the units, and making sure you have the right answer. So before we do that, let's jump over here and take a look at this. I put a poll up on my channel, on my community tab on my channel here, and I asked, how long should I stream for? And it's kind of interesting. Most folks think 30 minutes is a good amount of time to stream. Few people want it to be longer. I don't know, 60 minutes, maybe like during exams or something like that, where we just need to go over a lot of stuff. But I like the 30 minutes. So I'd be interested in hearing what you like in terms of a length of a stream. Do you like 30? Longer? How much longer? So anyways, that's a stream I put up, a poll I put up, and kind of interesting information. We're always trying to get information so we can make better decisions, either as scientists or otherwise. All right, Henry's at a bar right now. Excellent. Yeah, that would be the best time to learn moles to grams. And Sturban, I do like organic chemistry, but I'm more of an analytical chemist by training. That's where I did my work in the lab. All right, so here we go, moles to grams, grams to moles. So you could use this formula here to figure out converting moles to grams, right? If you were given the molar mass, you plug that in. If you're given grams, then you could find moles. But I like this method better. This is the kind of the easy way to remember, and then you can do the other ways as well. When you go from moles to grams, you multiply by the molar mass. Henry, I hope you appreciate there at the bar a little mole joke for you. Multiply by the molar mass. And this works really well. If you remember this, you go from moles to grams, you multiply by the molar mass. If you go from moles to, say, liters, you would multiply by 22.4. Moles to molecules, you multiply by Avogadro's number. So remember that mnemonic, and let's do some problems. Here is the first problem. Let's move this out of the way. Give this a try, and really do try to do this on a piece of paper. Figure out 3.21 moles of H2O to grams. Oops, that didn't work. There we go. Convert 3.21 moles of water to grams. And I've given you this information here so you can figure the molar mass of water out. All right, Junli thinks 30 minutes is good. Yeah. All right, welcome, Mystical Ocelot. I like that. All right, so let me give you the molar mass. Do I have the molar mass here? Here's the molar mass for water. So if you had trouble with molar mass, that's the molar mass for water. Put your answer when you chat in the chat when you get this, so I know some folks are doing it. All right, and that's where this came from. So we've got our 3.21 moles. We multiply by the molar mass, and remember our units are grams per mole, and we know we did it right because we have moles on top and moles on the bottom. They cancel out. You're left with grams. That's it. You're doing dimensional analysis here, or factor label, crossing the units out, left with grams. And we end up with, what did we get here? I don't see anything in the chat yet, but I have 57.8 grams of H2O. Yep, JP, you got it. The only thing I would say is, since you have 3 digits here, probably good to have 3 digits here. Excellent. So if you need help with molar mass, there is a link pinned in the chat. And so this is the video. That's not it. Where are we at? Here it is. These are the stats for the video that I have on molar mass. And in the past 48 hours, 3,194 people have watched the video on molar mass that's pinned up in the chat there. So if you're stuck with molar mass, watch that video with all these folks. You won't be alone. And make sure you get molar mass. All right, let's try another one here. How about convert 0.75 moles of calcium hydroxide to grams? And I give you the molar mass here, so you don't have to calculate that each time. Give it a try. And just remember, moles to grams, you multiply by the molar mass. And you know you've got it right because the moles, they cancel out. So what do we end up with here? Looks like we have 2 digits here, so 55.6. I think that is correct. I have 5.6 written down, but that doesn't make any sense. So let's go with 55.6, but make sure you put your units in. These canceled out, right? So we're left with grams. Yeah, he's got his units now. Perfect, grams. So always remember the units, because that's how you know you did it right. If the units don't cancel out, then something's wrong. All right, let's do one more moles to grams, and then we'll jump over and do some grams to moles, because the moles to grams is pretty easy. I wrote this a little differently to show you that we have grams over moles, so it's real clear here. Give this one a try. And this is our molar mass here. All right, so oops, I can just copy that down there. And we can see our moles cancel out. All right, Yashu from India. It's like morning in India, I think. So if you do this math here, you end up with 76.3, and that's going to be grams. But I want to show you something really interesting that your teacher may have tried to show you before here. We could take and just draw a line. Let's actually do a line here. You could just take a line across like this and then put a line like this. And you may have seen your teachers do this before. Get rid of that. And so they'll write it like this sometimes and call this the factor label method, or they'll call it conversion factors, dimensional analysis. The idea is that 1 mole of this acetic acid is 62.05 grams, right? So basically they're the same thing. They're equal, so you're just multiplying by 1 but it changes the units. So this is a conversion factor. It's the same thing, right? Moles cancel out. You're multiplying by the molar mass, and you get the same answer, but this looks kind of like you're a super chemist. Teachers get excited when you do this. So we're going to try to do a little bit more of this here to help you get that. All right. You guys ready for some grams to moles? Grams to moles. All right. So when I was taking chemistry, as I recall in high school, when we got to the moles unit, it kind of messed me up, and I didn't quite get the process for doing it. And then that kind of made me not like chemistry for a while till I figured it out. But once I figured it out, then it all seemed kind of easy. So if you're able to use the methods I'm showing you here, after a little while it just gets easy. Then you focus on kind of the important stuff that you need to. And you're a lot faster on exams. And that saves time, gets you higher scores. All right. So let's go over to my screen. Yeah, you wouldn't need 4 significant figures there. You probably would only go with the 3 because of that number. Yeah. All right. So we're starting to look at conversion factors now. So when we went from moles to grams, we multiplied, however this mnemonic helps you remember, by the molar mass. We found that by adding the elements up on the periodic table. So when we go from grams to moles, we just do the reverse. We divide by the molar mass. So in this case, we're just going to divide this by the molar mass. So let me show you that because it gets a little weird with the units here. We'll take our 12.2 grams and we're going to divide by the molar mass here. So let's put that over the molar mass, make it a little bigger. And so we're just dividing 12.2 by 60.01. So that would give us a number. What is the number? I think 0.203. Grams cancel out. And now we have 1 over moles. And just trust me, that gives you moles. So we're just dividing now by the molar mass, and that gets us from grams to moles. But there's another way we could do this. Let me show you that. And this is where students the 60.01 is the 1 carbon plus the 3 oxygens. So we have 1 carbon, we added that plus 3 times this number, and that's where we got that number that's the molar mass of the CO3. And you don't have to worry about the electrons. They really don't have much mass. Okay, so let's move this up here. And here's what we'll do. Maybe. We're going to multiply this here by the reciprocal. So we're going to say 1 mole of this CO3 is 60.01 grams. Remember that this is 1 mole of CO2. It weighs 60.01 grams. It's like dividing 1 by 1. This is just equals 1. But now we draw our bar here, put this here, multiply the top, grams cancel out, and you're left with moles. So 12.2 divided by 60.01, and that gives us the same answer. So your teacher probably is really going to like this cross method. They'll call it the factor label method. But really all we did was we multiplied this by the reciprocal of the molar mass. A little bit much to think about. So let's go down and give you a chance to try that. All right. So this one here, this is the molar mass for the CuSO4 with 5 water molecules around it. So there's your molar mass. There's your grams. Get it to moles. Take a moment to do that. And I'm going to drop my free PDF guide. I normally have this for channel members, but since you guys are here tonight, I'm going to give it to you. And this has a lot of practice with answers that go to other videos and so on. So this is the free guide. There you go. So it won't be up for a real long time, so you might want to download it if you want it. All right, so let's take a look at this. I would agree with you, Chun-Li, but I probably would go out to, is it 0.49? I think you might need one more significant digit there. So let's set this one up. I'm going to set it up 12.2 grams, and I could divide it by this here, but instead, I think what I want to do, and that would give me the answer, right? But I think instead I want to use that conversion factor. So see if I can do this. So I want to multiply this by 1 mole. That's our mole here. I know that 1 mole is 249.72 grams, because that's the molar mass. So what I'm doing here is I'm still taking 12.2 and dividing it by the molar mass, but now I've set it up like this here, and I draw my bar across here so I look like super chemist. Put this like this here. Some teachers call this a picket fence. You multiply the top, divide by the bottom, and you get the same answer we got before. 0.0489 moles, because this first zero is not significant. Grams cancel out. You are left with moles. You know you did it correctly. So that's kind of a powerful thing to do. And later on in chemistry, you can keep adding new things here, different conversions, and it kind of keeps everything straight. All right, where are we at? We've been going for 17 minutes, and let's do another one here. And this one is going to be a challenge. Railroad method. Yeah, I've heard it called that too. And mathematicians, they use this in physics to convert. Anytime you have to convert units, it's a nice way to use with conversion factors. So this one is kind of an advanced one. So take a look at that. How do you get grams to liters? That's not easy. You could convert grams to moles, and then from moles, we could go to liters. So it's like a multiple step problem. Grams to moles, and then moles to liters. So we'll need a conversion factor for liters. And it turns out that 1 mole is 22.4 liters. 1 mole is 22.4 liters. That's your conversion factor, or you could say 22.4 liters in 1 mole. So let me show you how to do this one, and then I'll give you guys a chance to try another one. 12.2 grams. And I know that I need grams on the bottom, and that's this number right here. So I can just drop this. Oops. That's not right. I need to have times grams on the bottom, so 16.00 grams in 1 mole. So all we're doing when we go from grams to moles, we divide by the molar mass. That's what we're doing here, but this cancels out. So we know we have moles. So now we have moles. We multiply that. We need moles on the bottom. 1 mole is 22.4 liters, and you can see moles, they cancel out. And now let's just put this over 1 here so it's easier to see that. Now we're left with liters, and we just multiply the top, divide by the bottom. I end up with 17.1 liters of oxygen. And Jason, looks like you got that too. And to impress your teacher, you put this line here across. You do the railroad method, as Jason called it there. And you can get rid of those. And chemistry does not get a lot more complicated than that. If you can do that, you are in really good shape. So we went from grams to moles and moles to liters. Lexi, you also got it by, I probably would round it to 17.1 since we only have 3 significant digits there. All right, last one, and we'll end here. I'm going to give you the conversion factors. 1 mole, you should know this, equals Avogadro's number of molecules. So we could say 1 mole over 6.02 times 10 to the 23rd. Or 6 over 1 mole. These are the conversion factors that we're talking about. Give it a try here. Really try to get this one. So you can see how we set this all up here. We have, we'll just put this over 1, and we can connect these like this. And again, get rid of that, put some lines through there, give us our picket fence, our railroad, and moles cancel out. We're left with molecules. And I would probably just 12.2 divided by 16.00. Well, actually, I would multiply this, and I would add this at the end. So I think we end up with 4.59. That's 12.2 times 6.02, and then divided by 16, and now just add times 10 to the 23rd on the end. That's it. So we kind of went off the deep end here with some of these problems. Good morning, Hatsma. We kind of went off the deep end with these problems, but you can see where we're going. If you know that you start with moles, you're going to always multiply by either the molar mass if you want grams, 22.4 if you want liters, or Avogadro's number if you want molecules. So whenever you go from moles to something else, you multiply. I'm going to write it in there for you. So kind of silly, but it helps you remember how to do all that. So that's it. We are up here at 23 minutes. So that's a good mix between our where we were at with the earlier survey. I'm going to stay on chat for a moment after I end the stream. If you have questions for me, I might be able to point you in the right direction. And we'll be back here again Sunday evening, 8:30 Eastern Standard Time. So thank you so much, everybody, for joining me here again. And as always, this is Dr. B. Thanks for watching.